Welcome to the Explainer. Today we're going to take a completely mundane human action and look at it in a totally mind-blowing new light. We spend so much time marveling at human achievements, our massive cities, the internet, our crazy complex social structures. But to truly get how we arrived here, we actually have to look past all that complexity and dig into something incredibly simple. We're going to explore how one single solitary action fundamentally re-engineered our biology, shaped our minds, and ultimately conquered the planet. And the crazy thing? It is probably the most basic, seemingly unintelligent thing you can possibly do.
Okay, let's dive right into this. Picture a little thought experiment. If you were suddenly forced to explain to an alien intelligence exactly why humans became the dominant species on a planet absolutely full of animals that are stronger, faster, heavily armored, and just packing way better natural weapons, what would you say? You'd probably guess our intelligence, right? Or maybe our complex language, or the fact that we mastered fire or invented tools. What you almost certainly wouldn't lead with is something much, much dumber.
Literally just throwing rocks. That's it, specifically the overhand throw. A human hunter accelerating a projectile to a super high velocity with pinpoint directional control. It looks embarrassingly simple. There's absolutely zero tactical sophistication to it. You just pick up a rock and you chuck it at something. And yet, this single, rudimentary little action is one of the most consequential physical abilities in the entire history of evolution. It completely tore up and reorganized the predator-prey dynamics of the entire planet, taking early humans from these vulnerable, medium-sized omnivores and turning us into the ultimate apex predators. Now, consider the sheer physical differences here. Every other great ape out there can throw. If you've been to a zoo, you've probably seen a chimpanzee get agitated and enthusiastically hurl something. But despite all that furious effort, a chimp absolutely maxes out at roughly 20 miles per hour. A trained human baseball pitcher, on the other hand, they can easily hurl a projectile at over 100 miles per hour. And the defining difference here isn't about practice. It's not about some deep cognitive understanding of pitching mechanics. It is purely 100% about our anatomy. Back in 2013, Neil Roach and his team at Harvard published some groundbreaking research on this. They found that human beings have a throwing arm that is configured differently from literally every other primate. We've got this highly mobile shoulder joint, a waist that can rotate completely independently of our hips, and highly specific proportions in our arm segments. And when you put all that together, it allows the human body to function exactly like a whip. So when you wind up to throw a snowball, your body is storing massive amounts of elastic energy during the cocking phase and then releasing it explosively. It's an anatomical setup that chimpanzees just flat out do not have. So why was this weird anatomical whip such a massive game changer? Well, for millions of years, there has been this continuous biological arms race between predators and prey. Basically, most predators have to close the distance to attack with their teeth or claws. Because they have to get up close and personal, prey animals have a fighting chance of injuring them right back. So predators slowly evolve to be stronger or faster, and prey animals evolve better defenses, thicker hides, faster legs, sharper horns. This co-evolutionary dance keeps both sides relatively balanced in close-quarters combat, which means throwing is basically an evolutionary cheat code. Just think about it. A prey animal's ability to kick or gore you with its horns or sprint away, all of that has been painstakingly calibrated by millions of years of evolution to defend against a close-range attack. But it has absolutely zero calibration for an incoming rock flying at it from 20 meters away. The fastest antelope or the most powerful Cape buffalo is rendered totally defenseless because throwing just bypasses their adaptations entirely. And we actually see this exact dynamic play out in the archaeological record. Whenever anatomically modern humans arrived in a new region, the local megafauna, we're talking massive, terrifying creatures like mammoths, mastodons, and giant ground sloths, they tended to go extinct super rapidly. And they didn't die out because early humans were somehow wrestling them to the ground. No, they vanished because they had zero evolutionary avoidance response to high-velocity projectiles hitting them from a distance. Throwing let humans inflict lethal injuries from a safe range, where the animal's massive size and terrifying strength were just completely useless. This was the exact moment we completely broke the fundamental rules of nature. We didn't have to wait for biology to catch up anymore. Unlike a predator's physical adaptations, which, take millennia of agonizingly slow genetic changes to evolve, throwing is culturally transmitted. A better throwing technique or a brand new hyper-effective spear tip, That can be taught through imitation in a single afternoon. That meant the arms race between human hunters and their prey was suddenly happening at the speed of cultural innovation, that is, thousands of times faster than biology allows. The prey literally couldn't mutate fast enough to survive us. Now, throwing didn't happen in a vacuum. It teamed up perfectly with another totally unique human capability: persistent hunting. Thanks to our bipedal anatomy and the way we sweat to cool down, humans can run prey animals to absolute exhaustion just by continuously tracking them at a moderate speed over long distances. So bipedalism lets us run an animal until it literally collapses, and throwing lets us safely finish the hunt without ever having to risk a desperate, dangerous close-quarters brawl. Combined, it was a hunting system with zero evolutionary precedent. But hey, let's pivot for a second, because just picking up a rock and hurling it isn't only a neat physical trick of the shoulder, it is a monumental feat of the mind. The cognitive demands of the overhand throw are absolutely massive. Generating speed relies on anatomy, sure, but generating accuracy, that relies on a staggeringly complex neural system. To actually hit a target, your brain has to do incredible, entirely unconscious math on the fly. Just think about the insane, real-time predictive computation happening in your head when you toss something. Your nervous system has to calculate gravity's trajectory, time muscle movements down to the millisecond, compensate for the mechanics of your own arm, and perfectly predict where a moving target is going to be, all in the blink of an eye. This extreme accuracy, driven by dedicated neural circuitry that we train all through childhood, is what actually makes human throwing a lethal threat rather than just a high-speed annoyance. And this leads to one of the most fascinating theories in human development: the ultimate recursive loop. The idea is that natural selection strongly favored individuals with better physical prediction systems for throwing. Better throwing made hunting large game viable and, crucially, safe. That successful hunting led to massive increases in high-quality meat, which gave us the dense nutritional calories required to grow even bigger, more complex brains. And what did those bigger brains do? They enabled even better motor planning and throwing. It's a grand irony. The dumbest physical skill and our brilliant, hyper-smart brains literally built each other over hundreds of thousands of years. We can actually map this out in the archaeological record. The anatomical potential for throwing first shows up about 2 million years ago in the shoulder of Homo erectus, which lines up perfectly with the earliest evidence of large game hunting. But then, it isn't until about 300,000 years ago that we see hafted stone spear points, tools engineered specifically for advanced throwing. And what about those incredibly sophisticated cultural artifacts, like flutes carved from vulture bones? Those don't appear until roughly 40,000 years ago. So, we were throwing things for millions of years before we were ever making music or art. The physical act of throwing predated our complex culture by an unimaginable amount of time. Zooming out even further, this massive advantage wasn't just reserved for hunting animals. It inevitably took a darker turn when we applied it to each other. The ability to inflict severe casualties on an enemy from a distance, long before they can even touch you, completely flipped the script on human conflict over territory and resources. Honestly, the entire history of human warfare and military civilization is largely just the story of us refining and elaborating on this one fundamental primate trick. Just trace the rapid historical escalation of ranged weapons. The bow and arrow extended our throwing range using elastic energy. Then the crossbow added mechanical advantage. The catapult let us throw things way too heavy for a human arm. The cannon brought chemical combustion into the mix. And today, a ballistic missile does the exact same thing using rocket launch technology. The specific delivery mechanism is constantly upgrading, but the underlying strategic principle, applying lethal force at a distance, faster than the target can possibly respond, that hasn't changed one bit. So what does this all mean? It leaves us with a pretty profound, maybe slightly dark, but endlessly fascinating reality to chew on. We love to pride ourselves on our sophisticated symbolic thinking, our gorgeous art, our music, and our massive cooperative societies. But the absolute core innovation that made us the most consequential predator this planet has ever seen, it was just discovering that you can kill something without getting close to it. What does it really say about us that our absolute dominance, our survival, and the explosive evolution of our intelligence were all kickstarted by the dumb, simple math of finding ways to hurt something before it can hurt us back? It's definitely something worth sitting with the next time you casually skip a stone across a lake. Thanks so much for joining me for this explainer, and keep questioning the simple things.